Again soon. Bye, JP. Okay, let's see. You prefer the PDF or the PowerPoint? The PowerPoint, okay. Okay, that's the PowerPoint. Excellent. All right, up next we have Marc Schoolaert, who is the Senior Consulting Engineer from Nokia Deepfield, and he's going to talk about using ML and AI, or AI and ML, depending on which way you like it, for better network and security insights. All right, Marc, it's all yours.
Thank you. So, good afternoon, ladies and gentlemen. Okay, so in the next 20 minutes, I'm going to show you how we use, well, a more practical use case of ML, which is being used today already by our customers, okay, and which we are improving further. So I'm going to explain you how you can use ML to enforce the defense, the security of your network, to better defend yourself against the big changes that we have seen recently over the last couple of months and even more in the last weeks in types of DDoS attacks that are attacking your networks. Okay? And how you can use the same ML technology to understand, to get full visibility of all the applications, of all the traffic types that are going through your network in the same way as you would get it from a DPI appliances, but without having to deploy DPI appliances in your network. Okay, so it's the same algorithms that are behind, and up to last year, about 50% of the engagements that we had with customers, questions that we had from new customers were about analytics, 50% were about security. To be honest, over the last 2 months, this has shifted in a big time, and now for the last couple of weeks, the last 2 months, 95% of the questions that we get from new customers are about, okay, how can we use this to enforce the security on our network? Okay, so that's also why I will focus more on security in this presentation. So, starting first to look at why you need ML for fighting DDoS or for protecting your network against DDoS. Okay. So one of the big reasons is the changes that we have seen. So traditionally, over the last 20 years, so since 2000, for the last 20 years up to about mid last year, the majority of attacks that you had on your networks and that we have seen around the world on all networks, they were using these 3 types of attack vectors or attack types. Okay, so there were the amplification reflection attacks, for example, DNS amplification reflection, where a hacker sends a large number of small DNS requests to a couple of hundreds of open DNS servers in the internet, and they trigger them to send, well, they ask them to send all the information that they have about a specific domain, so big responses. And instead of putting their own IP address in the request, they put the IP address of the victim, of the server that they want to attack. So all these hundreds of servers in the internet, they send all their big responses to this victim. And so your network, if this victim is in your network, these type of attacks, they can generate tens, even hundreds gigabytes of attack traffic, all flooding in your network towards the customers. Okay? Or other types of attacks were just using compromised devices to send crafted traffic, flooding of crafted traffic, synthetic traffic towards the victim. Okay. Or using application layer attacks. Okay, so application layer attacks which are more targeting weaknesses at the application level to cause harm to specific applications in the network. So it's mainly the first 2, and in particular the first one, which is generating the biggest volumes of DDoS attack traffic to your networks. And because they are the biggest volumes, okay, when you need to mitigate them in scrubbers, in appliances, in inline appliances, they are of course also the most expensive ones if you need to install more scripting capacity. So that has been like this over the last 20 years, and of course they invented new, well, we have seen appearing new vectors every year, but all these new vectors, they were always using kind of the same techniques. Okay, to attack, and also the mitigation techniques were all the same. But this has changed bigly. So we have seen a dramatic change starting mid next year, last year, where we have seen an incredible growth in the volume of DDoS traffic coming from botnets. Okay, so botnets have been around for a couple of years, but they were mostly used before just to start application layer attacks. Okay? But around mid last year, we saw suddenly a big increase in DDoS traffic, and the increase is so big that, as you can see on the chart on the right-hand side, where we graph the aggregate total volume of DDoS traffic that we see in a number of the networks that we monitor, okay, average per day, per vector. And in yellow, you see the total volume of traffic generated by DNS amplification vector, which has always been for the last year the biggest factor generating the biggest volumes of traffic. Okay? Somewhere beginning of this year, the volume of botnet traffic surpassed the volume of traffic being generated by DNS amplification. And just in a couple of weeks, it has surpassed it now by big time. Okay, so this change is really going very fast. It's going very rapidly. And when I talk about botnet attacks, we're not particularly talking or specifically talking about compromised hosts, compromised PCs, which were used before for application layer attacks. But we're really talking about traffic coming from all kinds of connected IoT devices, consumer devices like video recorders, which you can access online. If you forgot to program the recording of your favorite series when you're not at home, you can connect to them from remotely. Or baby webcams, which parents love to use when to watch if their baby is sleeping nicely when they are not immediately around. So all these devices, it's great that you can access them from the internet. But unfortunately, the majority of these devices, they are very easy to hack by a hacker to bring them under control of botnet. Okay, and so that is what we are seeing. And it's not just consumer devices, it's also business devices, like even parking meters, as we have seen in a couple of attacks earlier this year, where some of our customers, they were attacked by hundreds of parking meters. Okay, so now next time that you pay your parking ticket, you may be thinking that, okay, maybe while you are paying this parking meter is also attacking somebody on the internet. Okay? So it's basically any device. So right now, up to now, we see about 100,000 devices being actively part of DDoS attacks every day. But okay, there is a potential for millions. Okay, there are 100,000 that we see active every day. There are another 100,000 for the moment that we see from time to time being active. So this is a changing thing. But it's really the big amount of devices which are out there and which are potentially targets to become part of botnets to grow even further. Okay, and so this slide explains then why you need a new technology. So why the scrubbing technology or the traditional technologies that were used by scrubbers can no longer be used also for botnet attacks. And why do you need machine learning? Okay, scrubbers have always been successful in mitigating DDoS attacks by looking for patterns in the packets headers, packets in the payloads, okay, patterns in the traffic levels, or by sending basic protocol challenges to see if there was really a device on the other side of the session, of the TCP session that was being sent. Okay. DDoS traffic coming from botnets is completely different. So in this time, there are real devices behind it. Okay, so traditional traffic was coming from was using spoofed IP addresses. There were not real devices behind. Okay, it was just being reflected or poorly crafted. Now, traffic from botnets is coming from real devices that are using real IP addresses. It's no longer spoofed IP addresses. They are using real OSs that have the full TCP stack. So even when you send them challenges, these devices will respond to the challenges. Okay, and the rules that you used before, they break. We see that more and more these botnets, they are sending encrypted traffic, so encrypted HTTPS traffic, okay, and they do it in an intelligent way such that statistically seen, you can no longer differentiate this attack traffic from web traffic, okay. So while we used before patterns in the packets and in the payloads to identify if the traffic was DDoS or if it was legitimate traffic, Today there are no longer patterns that we can look at in the headers or in the payloads. Okay, so where in the past it was a relatively simple machine learning exercise where the machine learning could be done locally on an inline device, analyzing the traffic as it went through the device. Today, the problem has become different. It has become a big data problem, okay, where we really need to, well, if you cannot look inside the packets anymore to see if it is the DDoS or not, you need to look at the global scale, okay? You need to look at the scale of the internet to understand all the devices, which devices are sending this traffic, what are the models of this traffic. Okay, so in practice, how do we provide a solution for that? Okay, the first thing that we do is building a bit the equivalent of Google, okay? Crawling the whole internet to collect all the information about all connected devices in the internet. Okay, to build maps of the supply chains of all the traffic coming from the internet. Okay, and look, then analyze tons of data, and I have another slide with a bit more details about that, to really build the models of every IP, every device, every application, every service in the internet, every IoT device also. Okay, continuously feed this with tons of data to update it. Okay, and then we combine this global map, this global bunch of data, with all the telemetry in the deployments at our customer networks. We combine it with the telemetry that we get from the network to correlate this information and to use the rules and the models that we build globally to learn by looking at the traffic from, okay, is there an attack going on inside the network of this customer? Okay, so we look at it in real time. We build peacetime models to understand for each protected object what is he normally doing, what kind of traffic is he normally generating, such that we can always compare them. Okay, and this allows us then to detect when there are DDoS attacks, even when it comes from botnets. It allows us to build the filters that can be used to block this botnet traffic, which can then be pushed towards the servers. Okay. So the first part, building this big map, building the supply chain of all the services in the internet, of all the devices in the internet, and the security map. Okay, I mentioned it already. Okay, the way we do it, we start from the same technology that Google uses. Okay, just by crawling every IP in the internet, every IPv4, every IPv6, to learn all the connected devices, server types. Okay, who owns them? In which CDN are they located? What are the ports that are open on the service? What are the applications that are running from there? What are the IoT devices? Okay, what type of IoT devices? Which OS do they do? Which vulnerabilities do they have? And then we combine it with huge amounts of data, of traffic flow, to build models. Okay, using all kinds of classification, clustering techniques, to build the models of legitimate applications. Okay. And then also, of course, of all the DDoS types of traffic, all the DDoS factors. Okay? Plus also, which of these devices do we see taking part actively in DDoS attacks, which are part of botnets. Okay? And so we classify them, all the IoT devices. Okay? These are the ones that we see actively. These are the ones which we haven't seen active yet, but which have the potential to become part of a botnet. Okay, and we bundle this information. So all this is built on the servers in the cloud. Okay, so once we build this and we continuously feed this with data to keep it up to date, we bundle this in 2 streams, which are then downloaded or sent to the servers. So to the second part of the solution, it's Deepfield software which runs on servers in your networks, in the operators' networks. Okay, so that's the part in the square at the right. This is the customer domain. Okay. By combining this, so we run this on the servers, which are just standard servers, which collect also the telemetry flow data from all the routers in the network, okay? Such that we learn all the traffic that goes through the network. Okay, so there is no traffic being diverted to these servers. It's just based on the telemetry that we receive, source, destination, IP addresses. We use this in our models to detect, okay, suspicious flows. No longer looking for patterns in the payload or in the packets, but just based on, okay, where are these flows coming from? What kind of devices are sending these flows? Are it caches in Netflix domain, which are just filling the caches, local caches in the operator's network? Or are it IoT devices? And if it is just a couple of IoT devices sending some traffic, it may be completely legitimate. But if we cluster this and we see lots of flows like this with a high risk factor or a high threat level coming, then we are pretty sure that yes, there is a DDoS attack going on. Okay, so in this way, we can detect, identify DDoS, and then we can use again our model and our printing of all the botnet vectors to build filters to block this DDoS traffic. Okay, and then the filters, we send them to the routers. Okay, to the routers, we rely on the routers to filter the traffic there and to block the DDoS traffic in the most efficient point in the network. And of course, there is a feedback cycle to monitor. If the attacks change, is the pattern change, we need to adapt it. Of course, I always say the proof of the pudding is in the eating. And so for a machine learning-based machine solution, it is based on the validation test results. Okay, and so we have this deployed in nearly 100 networks over the world to identify all the applications, all the legitimate services around the world. Okay, so for these ones, we know this works, and this has been proven that it works much better than a DPI-based solution, just because we don't suffer from the fact that everything is now encrypted. For the DDoS, it is deployed in a number of the deployments, and then in our labs, we test this on a continuous basis against a large base of all the DDoS attacks that we capture and monitor across all our networks. Okay? And the conclusion is really that, yes, you can use such a machine learning solution to identify DDoS as good or much better, in fact, than scribbling appliances. And you can block all the DDoS traffic with minimum false positives on scalable routers. Okay, so we can block 100% of all the DDoS traffic. Now, blocking 100% of DDoS traffic is not difficult. Okay, just install one filter to block all the traffic towards the target, and you block 100% of the traffic. So the trick is, or the difficulty is in blocking all the DDoS traffic towards the target while leaving or while letting pass all the legitimate traffic go through, such that his services are not interrupted. Okay, and there it really becomes a factor of the scaling of the router. So how many filters can we install on the routers? Okay, and so for the traditional DDoS vectors, like the amplification reflection attacks, typically with 100, 200 routers is sufficient. We can block 100% of the DDoS traffic and let pass 100% of the legitimate traffic, no problem at all. So this can be done on any routers. But when the traffic comes from botnets, it becomes much more complex. And then we need to use a combination of bigger whitelist filters and blacklist filters. Okay, and then it becomes a question of scale of the routers. Okay, if you can install a couple of thousand, 2,000, 3,000 filters on the thing, you can get up to ratios of, yes, you can block 100% or 99% of the DDoS traffic, and still let through 80% of the legitimate traffic. If you can go higher, like on Nokia routers, where we have no problems installing 10,000, 20,000, even more filters on a router, then you can reach high levels where you can let pass 95, 98% of the legitimate traffic. Okay, so I think the biggest advantage is this: since everything is done now offline, and I get the sign that I need to close up, so I'll jump to my closing slide. So in summary, it's really the fact that now we use big data analytics. So we do all the processing. So the modeling is done completely offline in the cloud. And then the detection within the network, we collect just the net flow from every edge from the network, from all the routers. Okay. And then we install the filters on these routers. Okay. We no longer need to divert DDoS traffic through scribbling alliances. So that allows us to provide, or that allow you to provide DDoS protection at every edge of your network for any kind of attack for every customer. So no longer just limited to the happy few who can pay a lot of money to have the protection, but any customer, because ML allows to do this at a much lower cost point. Okay, thank you. Of course, 20 minutes is a bit short to go in details, but we will be happy to discuss more details on the Nokia booth. Thank you.